Okay, hello students. So now again we are here to discuss about the shapes of the covalent molecule, and just for a short reminder, shape of the covalent molecule can be decided on the basis of valence shell electron pair repulsion theory, that is BS-EPR theory, and it can also be decided on the basis of hybridization, that is intermixing of orbitals. In brief, in brief, during hybridization, orbitals of outermost shell of central atom intermix with each other. This phenomena is called as hybridization. They form new orbitals of equivalent energy and shape, which arrange themselves in different directions and give shape to the molecules. Number of or newly formed orbitals are called hybrid orbitals, and the number of newly formed orbital is exactly same as the number of orbitals are intermixed. And if we want to discuss really the hybridization, because it tells about the shape of the molecule, so it is always better to pick an example and then to explain the type of hybridization. Now today in this video we will discuss some patterns, some examples of hybridization which involves s, p and d orbitals also. I think you can remember in previous video we discussed the involvement and intermixing of s and p orbital. Now we will discuss about the intermixing of s, p and d orbitals. Very clear. So on this basis we have to discuss about some different types of intermixing which are involving sp and d orbitals. Let us take an example. We have to talk about a hybridization which involves sp and d orbital, and let me have to talk about sp3d type of hybridization. This kind of hybridization we have to discuss. sp3d type of hybridization we have to talk. Now it's very clear. जब हमने बोला sp3d, what does it mean? It's very clear. मैंने बोला था आपको पहले भी, whatsoever hybridization we discuss, it depends कि which orbitals are actually intermixed. हमने बोला sp3d hybridization means एक s, 3p and 1d orbitals are intermixing together. Total how many orbitals are intermixed? You check. 1s, 3p, 1d. Total 5 orbitals are involved in hybridization. Let us take the example of molecule called PCl5. हम PCl5 molecule का example लेते हैं. Central atom क्या होगा इसमें? Correct. जो less होता है, आपने सही बोला, phosphorus is the central atom. Atomic number of phosphorus 15. Configuration 1s2, 2s2, 2p6, 3s2 and 3p3. Now on the basis of previous video what we discussed, tell me how many unpaired electron phosphorus should have? Since phosphorus has to bond with 5 chlorine atom, so phosphorus should have 5 unpaired electrons. Phosphorus should have 5 unpaired electron in 5 orbitals which will undergo hybridization and will result the formation of molecule. Now what do we find? This phosphorus right now, if you observe, its configuration is 3s2, its configuration is 3p3. Now if you observe very clearly, the configuration we are writing 3p3, that is 3 unpaired electron, and in 3s there is 1 paired electron. यहाँ 3 unpaired electron है और यहाँ एक पूरा पेयर. हमने बताया बॉन्डिंग में वैलेंस शेल का इलेक्ट्रॉन्स इन्वॉल्व होंगे, तो हमें सिर्फ इस पे फोकस करके चलना है. फाइन। तो हमने कहा अभी फिलहाल इसमें 3 अनपेयर इलेक्ट्रॉन है और हमको चाहिए फास्फोरस में 5 unpaired electron because phosphorus has to bond with 5 chlorine atoms. Now how is it possible? Phosphorus outer shell third. Now when the phosphorus has outer shell third, it's very clear to all of us कि third shell में 3s orbital भी होता है, third shell में 3p orbital भी होता है और third shell में 3d orbital भी होता है. Though it is vacant, but we have 5d orbitals. Now सिचुएशन क्या बनेगी? क्योंकि फास्फोरस को 5 अनपेयर इलेक्ट्रॉन करने हैं, तो what does it mean? One electron will be excited, will be shifted, will be transferred from 3s to 3d. We will say now phosphorus get its excited state. Don't touch these in inner orbitals. ये bonding में involve ही नहीं है. सिचुएशन क्या बनी? नाउ 3s 1 अनपेयर, 3p 3 अनपेयर एंड 3d 1 अनपेयर. फास्फोरस को 5 अनपेयर इलेक्ट्रॉन चाहिए थे 5 क्लोरीन से बॉन्ड करने के लिए. फास्फोरस के पास 5 अनपेयर इलेक्ट्रॉन्स आ गए. 1 2 3 4 5. 1 unpaired in 3s, 3 unpaired in 3p and 1 unpaired in 3d. 5 unpaired electrons it got. Right? अब हमने क्या बोला था? जिन ऑर्बिटल्स में अनपेयर्ड इलेक्ट्रॉन्स होंगे, इलेक्ट्रॉन का प्रमोशन भी हुआ, ये 5 orbitals will undergo intermixing. These 5 orbitals, according to this concept of hybridization, these orbitals will hybridize. These 5 orbitals will intermix, and when they will intermix, they will undergo a kind of hybridization. You check it yourself. S का एक ऑर्बिटल मिक्स हुआ, P के 3 ऑर्बिटल मिक्स हुए, D का 1, S1 P3 D1. We will call it as sp3 dehybridization. Make it short. This is sp3 dehybridization. 5 orbitals will form. These 5 sp3, what you will call? Now none of the orbital is s orbital, p or d. यहाँ कोई भी अकेला ऑर्बिटल sp d नहीं है. हमने पढ़ा these orbitals will redistribute their energies. These d orbitals and these all orbitals will redistribute their energy and will make equivalent orbitals. Equivalent means बिल्कुल एक जैसे एनर्जी में, शेप में. तो हमने हर ऑर्बिटल को बोला sp3d hybrid orbitals. None of the orbital is s orbital or p or d, rather each orbital is to be called as sp3d hybrid orbital, and very clearly each orbital has one unpaired electron. हर ऑर्बिटल के पास एक अनपेयर्ड इलेक्ट्रॉन होगा. अब ये 5 ऑर्बिटल बने, क्यों इंटरमिक्स हुए समझ में आ गया. 5 अनपेयर चाहिए थे, एक इलेक्ट्रॉन को डी में जाना ही था, वो सभी 5 ऑर्बिटल मिक्स हो गए और जो मिक्स हुए उसमें एक s का था, 3 p के थे, एक d का था, इसलिए हमने इसको नाम दिया sp3d hybridization. Now these hybrid orbitals will arrange themselves in trigonal bipyramidal geometry. ये जो 5 ऑर्बिटल हैं अपने आप को अरेंज करेंगे, अपने आप को एडजस्ट करेंगे इन ट्राइगोनल बाइपिरामिडल ज्योमेट्री. व्हाट डज इट मीन? शेप सबकी सेम होगी. मैंने प्रीवियस वीडियो में भी बताया था, बाइलोब्ड होंगे. वन लोब विल बी ऑफ स्मॉलर साइज, अदर लोब विल बी ऑफ लार्जर साइज. स्मॉलर इट डजंट हैव इलेक्ट्रॉन, छोड़ दो. लार्जर इट हैज इलेक्ट्रॉन. और ये भी बताया था कि ये हाइब्रिड ऑर्बिटल कौन सा बॉन्ड बनाते हैं? सिग्मा बॉन्ड. करेक्ट, हेड ऑन ओवरलैपिंग होती है. You check it now. This is phosphorus with five hybrid orbitals. This is one hybrid orbital, this is second hybrid orbital, and this is third hybrid orbital. These 3 hybrid orbitals are in a plane, what we call sp3d. sp3d, each orbital is to be designated as sp3d hybrid orbital with one unpaired electron. One sp3 hybrid orbital. Now these three are in a plane. And what do we find? One sp3d hybrid orbital above the plane and other is below the plane. ये 5 ऑर्बिटल्स ने अपने आप को अरेंज किया. In each orbital, you see now, we are talking about chlorine. फास्फोरस के साथ क्लोरीन बॉन्ड कर रहा है. क्लोरीन एटॉमिक नंबर 17, 1s2, 2s2, 2p6, 3s2 and 3p5. This is 3p5. 3p5 means 1, 2, 3, 4, 5. One orbital with one unpaired electron. So this is chlorine which will overlap head on. This is chlorine which will overlap head on. This is chlorine with its p orbital will overlap head on. Chlorine will overlap head on. Chlorine will overlap head on. This is the shape. This is a molecule. Now what do we find? This is phosphorus. 3 chlorine atoms are in a plane. One atom, chlorine atom above the plane, and this is because of you got this shape. This is called trigonal bipyramidal, and you get it because of sp3d hybridization. And what do we find when we say this is sp3d hybridization? We have more orbitals involving d. You just see now. So now let us take another example of hybridization involving sp and d orbitals, and this is termed as sp3d2 hybridization. Now what does it mean? How many orbitals are intermixed? 1s, 3p orbitals and 2d orbitals. Total 6 orbitals are hybridized or they intermixed. And as usual, if you want to understand, it's better go after an example. And let us take the example of molecule called SF6. Now let us consider in this SF6, what is the central atom we have? Sulfur is the central atom. And one more thing, I am asking to you, if sulfur is the central atom and is bonded with 6 fluorine atoms, so 6 fluorine means सल्फर के पास कितना अनपेयर्ड इलेक्ट्रॉन होना जरूरी है? करेक्ट, सल्फर के पास 6 अनपेयर्ड इलेक्ट्रॉन होना जरूरी है. नाउ दिस इज सल्फर. This is sulfur with atomic number 16 with configuration of 1s2, 2s2, 2p6, 3s2 and 3p4. And as usual, जब सल्फर का आउटर शेल थर्ड है तो उसमें s और p के साथ d ऑर्बिटल भी अवेलेबल होगा. फॉरगेट, ये बॉन्डिंग में कहीं जा ही नहीं रहे हैं तो इनको हम पढ़ेंगे भी नहीं. हमने 3s में देखा 2 इलेक्ट्रॉन्स, हमने 3p में देखा 4 इलेक्ट्रॉन्स 1 2 3 4, हमने 3d में देखा ये बिल्कुल वेकेंट है, नथिंग इज देयर. नाउ सल्फर right now it has 2 unpaired electrons only, so it is able to form 2 bonds, but it has to form 6 bonds. It needs 6 unpaired electron. How it is possible? Again promotion of electron. Sulfur get excited, electron shifted, 1 electron shifted from 3p to 3d, and simultaneously 1 electron shifted from 3s to 3. तो एक इलेक्ट्रॉन शिफ्ट होकर 3p से 3d पहुंचा है और एक इलेक्ट्रॉन 3s से 3d पहुंचा है. This is sulfur is in its excited state. What do you get? 3s में there is 1 unpaired electron. 3p में there are 3 unpaired electron 1 2 3. 3d में now there are, you see, 1 shifted from p, 1 shifted from s. It has 2 unpaired electrons. Now 1s, 3p and 2d orbitals. Total how many orbitals? 1, 2, 3, 4, 5, 6. These 6 orbitals will intermix. And when 6 orbitals will intermix, but natural, 6 new orbitals will form. 1, 2, 3, 4, 5, 6. Each is having 1 electron. And one more thing, since during this intermixing, during this hybridization, 1s, 3 p orbitals and 2 d orbitals are intermixed. d के 2, p के 3, s को 1, तो हम इसको बुलाएंगे sp3d2 hybridization. And secondly, what I told, each orbital, now none of them is called as s or p or d orbital. As I discussed in previous case, आप किसी भी orbital को s, p या d नहीं बुलाओगे, rather what you will call, each orbital is called sp3d2 hybrid orbital. Remember, so simple. Now these 6 orbitals will same, what shape they have? Bilobed. एक बड़ा लोब होगा और एक छोटा लोब होगा, just to make it easy. छोटा लोब, no electrons. Larger lobe, larger size lobe means all electrons are there. These 6 orbitals will arrange themselves in an octahedral geometry. Octahedral. Octahedral means 4 orbitals will be in a plane. These 4 orbitals are in a plane. आप हर ऑर्बिटल को क्या बुलाएंगे? sp3d2 hybrid orbital. sp3d2 hybrid orbital. 4 orbitals are in a plane. 1 orbital above the plane. These are 4 in plane. 1 above the plane, other below the plane. इसको भी आप बुलाएंगे sp3d2 and this is also termed as sp3d2 orbitals. Each orbital has 1 unpaired electron. हर ऑर्बिटल का एक unpaired electron. किससे ओवरलैप करेगा? f ऑर्बिटल से. फ्लोरीन, this is fluorine, atomic number 9, configuration 1s2, 2s2, 2p5, 2p5, 1 2 3 4 5. अब जो p का अनपेयर्ड इलेक्ट्रॉन के साथ ऑर्बिटल है वो हेड ऑन ओवरलैपिंग शो करेगा, सिग्मा बॉन्ड बनाएगा. एज यूजुअल, दिस इज फ्लोरीन overlapping head on. This is fluorine 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 head on. This is fluorine head on. SF6 molecule I am talking about. बस sulfur you adjusted 1 2 3 4 fluorine atom around sulfur in one plane, one sulfur above the plane, other sulfur below the plane, and geometry is to be known as octahedral. This is geometry and this is to be called as octahedral geometry. This is when you get, when again d orbital is involved and we have sp3d2 hybridization, and similarly involving d orbital we have one more kind of hybridization. So now see, there is another kind of hybridization I am talking, sp3d3, again involving d. Now अब आप मुझे काउंट करके बताओ कुल कितने ऑर्बिटल्स इन्वॉल्व होंगे हाइब्रिडाइजेशन में? करेक्ट, s का 1, p के 3, d के 3 and total, in total 7 orbitals are involved in hybridization. 7 orbitals are involved in intermixing. And just to understand, we have a molecule called IF7. Iodine is the central atom. Iodine, its atomic number is 53, and to make it easy, मैं सारा configuration लिख करके मैं आपको बोलता हूँ. Its configuration is 2, 8, 18, 18, 7. First shell, second shell, third shell, fourth shell, and this is fifth shell. But this configuration comes to be 5s2 and 5p5. It's but natural. Fifth shell, 5d orbital will be available. अब एक क्वेश्चन हो, आयोडीन के पास कितने अनपेयर्ड इलेक्ट्रॉन होने चाहिए? करेक्ट, 7, क्योंकि इसने 7 फ्लोरीन से बॉन्ड करना है. फास्ट, वेरी गुड. अब आपके पास सिचुएशन क्या बनी? यू चेक इट नाउ. 5s2, भूल जाइए बाकी ऑर्बिटल, नॉन बॉन्डिंग. 5p5 and this is 5d. 1 2 3 4 5 and this is 5d. 1 2 3 4 5. Now right now this iodine has only one unpaired electron, but it needs 7 unpaired electron. promotion of electron. Now see, from P it is shifted to D, again from P it is shifted to D, and from S it is shifted to D. 3 electrons were promoted, 2 from P to D and 1 from S to D. Now you check it now. What do we find? In 5S there is 1 unpaired electron. In 5P there are 1, 2, 3 unpaired electron. And similarly in 5D how many unpaired electron? देखो एक P से शिफ्ट हुआ 1, दूसरा P से शिफ्ट हुआ 2, तीसरा S से शिफ्ट हुआ 3. Now total count 1, 2, 3, 4, 5, 6, 7 unpaired electron what we needed to bond with 7 fluorine atoms. 7 fluorine थे, 7 unpaired electrons आ गए. अब unpaired electrons किस ऑर्बिटल में है? एक S में है, 3 P में है और 3 D ऑर्बिटल्स में. ये सब इंटरमिक्स होंगे और जब सभी इंटरमिक्स होंगे तो मेरे ख्याल आपको बहुत अच्छे से समझ में आ रहा है. व्हाट यू विल कॉल इट एज सर sp3 d3 hybridization. So this is called as sp3 hybridization. 7 orbitals, 1s, 3p, 3d, total 7 orbitals are intermixed. So total 7 new orbitals are formed. 1, 2, 3, 4, 5, 6, 7. None of these orbitals, I am repeatedly telling you, कोई भी ऑर्बिटल ना s कहलाएगा, ना p कहलाएगा, ना d कहलाएगा. Each orbital is called as sp3 d3 hybrid orbital. Each with 1 electron. सभी सातों ऑर्बिटल में एक एक इलेक्ट्रॉन नजर आएगा. 1, 2, 3, 4, 5, 6, 7. शेप क्या एक्वायर करेंगे? पेंटागोनल बाइपिरामिडल. पेंटागोनल 5 in a plane, bipiramidal 1 above the plane, other below the plane. This is iodine. शेप बिल्कुल वही आएगी जो हम आपको बार-बार बता रहे हैं. This is iodine 1, 2, 3, 4, 5. 4 and this is 5. 1, 2, 3, 4, 5. हर ऑर्बिटल को आपने sp3 d3 हाइब्रिड ऑर्बिटल करके बुलाया. Each orbital is what you will call, each orbital is sp3 d3 hybrid and each is having 1 unpaired electron. हर ऑर्बिटल में आपको एक एक unpaired electron मिलता है. It's very clear. Now what next? Fluorine आपने देखा. Atomic number of fluorine is 9. Its configuration comes to be, listen carefully, its configuration comes to be 1s2, 2s2 and 2p5. Now 1, 2, 3, 4, 5. Situation क्या बनेगा आपके पास? You check it now. This is fluorine. ये इसका p orbital जिसमें unpaired electron है. ये head-on overlapping show करेगा. This is fluorine atom. ये head-on overlapping show करेगा. This is fluorine atom. ये head-on overlapping show करेगा. This is head-on and this is also head-on. Shape क्या आ गई? This is iodine in the center. 1, 2, 3, 4, 5. 7 orbitals in a plane. You check it now. This is 1 fluorine, 2nd fluorine, 3rd fluorine, 4th, 5th, 6th, 7th. इसकी shape आएगी and this is what we call pentagonal bipyramidal. इसको हम बोलेंगे pentagonal bipyramidal. So this is the shape of the molecule. What we are talking about. This is all different types of hybridization which are involving d orbitals along sp. I hope you understood the concept. Watch this video again and again just for a better explanation. Thank you.